video will review the Georgia Standards of Excellence 3 MD7, which focuses on relating area to multiplication and division. Part A of 3 MD7 states that students will find the area of a rectangle with whole number side lengths by tiling it, and show that the area is the same as would be found by multiplying the side lengths. Part B states that students will multiply side lengths to find areas of rectangles with whole number side lengths in the context of solving real-world and mathematical problems, and represent whole number products as rectangular areas in mathematical reasoning. Part C states that students will use tiling to show in a concrete case that area of a rectangle with whole number side lengths A and B plus C is the sum of A times B and A times C. Use area models to represent the distributive property in mathematical reasoning. When finding area, it is important to implement real-world tasks. In the Plan a Garden task, students were encouraged to use colored square tiles to design a rectangular garden that has a rectangular section for 4 different vegetables. Students can be given a required number of square units to use, or the task can be more open-ended with some limitations as to the overall size. After the design is complete, students write an equation to find the area of each section, and then write a final equation that shows how to find the area of the entire garden. This student designed a garden with the length and width of 6 yards. He then calculated the area of each section before finding the total area of his garden. So how can we find the total area of your entire garden?
Well, 2 times 6 is 12. And 4 times 3 is 12. And together is 24.
Okay.
And both these equal 6. And so 24 plus 12 equals 36.
While this model has the same area of 36 square yards, the dimensions are quite different. In another situation, a student designed a garden with the dimensions of 3 and 9 yards for a total of 27 square yards. So, what are these called?
These?
Each part.
These are partial products, is what you call them.
Okay, so what do we need to do now?
Now I'm going to add all my partial products together to get my product.
Another activity that incorporates the distributive property is the design a pool task. The guidelines state that the pool must have an area of 36 square feet, and it must be made from 2 different rectangles that are joined by one side. In class, we decided to have a shallow end and a deep end to our pools, which you can see by the shaded sections. Students found the area of each section to confirm that the total square footage is 36 square feet. Most importantly, they discovered that the width and length of the pools could vary while still maintaining the requirement of 36 square feet. How big is your pool?
My pool is 36 square units.
And what is the length and width of your pool?
6 by 6.
So how big is the shallow end?
It is 6 by 3.
What about the deep end?
Also 6 by 3.
So how did you figure out that that equaled 36?
I added 6 times 3 and 6 times 3, which is 18 on both of them. Then I added that up, which is 36.
In Unit 3 of the Georgia Frameworks, you will find a variety of tasks that support 3 MD7. In this 3-act task, students are presented with a visual of an Olympic cola display. The following videos will show how a student used what he noticed and what he wondered about the illustration to solve a variety of area problems. So what did you notice with the picture?
I noticed that the USA thing is made of sodas. I also noticed that there is about 100 packs in it.
Well, what do you wonder?
I wonder the area of the picture and how did they build it.
What's your main question that you have?
My main question is, what is the area of the USA?
So how did you find the area of the USA?
I counted the letters separately. So the U is 13 square units, the S is
17 square units, and the A is 16 square units. And then on the side over here, I counted them up and I got 46.
After finding the area of the letters, the student then decided to find the area of the background around the letters.
And put 7 over here, 23 right here.
Do you know what 7 times 23 is?
No, but I can split it up like this into 10, 10, and 3.
Okay, so how could you find the area of each section?
I can do 7 times 10, 7 times 10, and then 7 times 3.
So what was the total area?
Here, 70 plus 70, 140.
Okay, so 140.
40.
And then
140 plus 21, equals 161.
so if you know the area of the letters is 46 and the area of the entire picture is 161, how can you find the area of the background by itself?
Well, I can do 161 minus 46 equals blank, but I can do it on the number lines.
You can find the difference on the
Find
number
the
line?
difference on the number line.
So what would be the difference if you add up 4 plus 100 plus 11?
115.
As students extend their thinking and begin to solve problems with larger arrays, they develop a rich understanding of using partial products, which is a critical foundational skill for 4th and 5th grade multiplication. In the following video, students will use base 10 blocks to model partial products. This task can also be found in Unit 3 of the Georgia Frameworks. So how can you multiply 12 times 7 to find the total number of square units?
Well, you can break apart 12 into 10 and 2, and then put 7 over here, and then multiply 10 times 7, which will equal 70.
Okay.
And then 2 times 7 would be 14.
So how can you find the total number of square units for 12 times 7?
You can add the 70 and add the 14, and you will get 84 square.
Assessment items for 3MD7 can be quite diverse. Students could be asked to find the area of a figure with a known length and width, or they could be given a more rigorous problem which states this shape is a square with a length of 10 feet. Since a square has 4 equal side lengths, then the area would be 10 times 10 or 100 square feet. Students may also be provided with an illustration such as this that shows the top of the refrigerator is 5 feet with 2 feet at the bottom for the freezer. Explain how to find the total area. For additional tasks and resources, please check out Unit 3 of the Georgia Frameworks. Unit 4 also expands on area while introducing perimeter. Through these rich tasks, students will be able to apply their understanding of both area and perimeter.